All right, let's see what we got. AC, this is review number 3, number 12. AC, DC, BA, ED. And let's see, where are the triangles I'm trying to prove? ACE. If you guys want to bring highlighters or colored pencils, feel free. And BA, DCB. So these ones on the outside. All right, everyone sees I already have a pair of sides, correct? I already have a pair of sides. All right, what type of triangle is it? The whole thing's isosceles. Everyone see that? Even though I didn't say it, if AC and CD are equal, triangle ACD is isosceles. What's across from the congruent sides? Congruent angles. Angle A and angle D have to be congruent. In a triangle, congruent angles are across from congruent sides.
You say like in an isosceles triangle?
You better call it isosceles first because I never said it was. So if you start with in an isosceles triangle, I'm probably going to write, where's it isosceles? So in step 2, your step 2 might want to be, hey, triangle ACD is isosceles. It has 2 congruent sides. Then you can go there. But you got to call it isosceles first. All right, because I didn't do that in the givens. In a triangle, congruent angles are across from congruent sides. All right, so that gives me an angle now. And then one more side or angle, right? And I'm going to use these givens here, that BA congruent to ED. I'm going to use subtraction, it looks like. But first I have to say EB is reflexive. And then I'm going to do my subtraction substitution. And then what's my reason going to be? I believe it's going to be side, angle, side. Good there, Nate?
Yeah.
Sure?
Yeah.
Other questions? Review 3. Yep, ours. 6. What conclusion can I make? All right, so I'm going to need all right, try something else. We will give you graph paper. All right, scrap graph paper that you can recycle after the midterm. You don't need to hand it in or look at it. This might be a good problem to use that scrap graph paper. Let's see, paste. And then can I get the grid now? Yep, there we go. Okay, I want to take a look at the graph, -1, -2, -1, 1, 2, 1, 2, 3, 4, 5, 6, C. Okay. Probably a couple of these. ACB is 90. I think we can get rid of that one, right? Angle A congruent to angle B, maybe A and C congruent. I don't know. ABC is 60. All right, so the only way I'm going to figure out if these angles are equal or maybe even angle ABC is 60 is determine the side lengths to see what type of triangle it is. All right. So AB, 1, 2, 3, that's a distance of 4. How can I find the lengths of BC and AC? Distance formula. All right, so I do the distance on BC and AC. I'm going to cheat here. 1, 2, 1, 2, 3, 4, 5, 6, 7. Square root of 53. 1, 2, 3, 4, 5, 6, 7. That's also the square root of 53 when I do the distance formula. What do I notice about the triangle? It's what type? It's isosceles. What's across from these congruent sides? Congruent angles. So that's how I knew A and B were equal. Now, why would I pick choice 4 ever if this was equilateral? All All right, because remember, if a triangle is equilateral, all three sides are equal. That means all three angles are equal, which means they have to be 60, 60, 60. So if I found all three sides were equal, then it would be ABC would be 60. And I guess that would be true. That would be, a bunch of them would be true. So that's why it's only one then. Good, Iris? Just had to find the side lengths using distance formula. Anything else coming up? Eliona? 8? Which statement is sufficient enough to prove A, B, C, D? All right, let me blow this up first. A, B, C, D. All right, let's go through the choices and why or why not it doesn't make it a parallelogram. 1 and 3. What type of angle? Here you go. Great review here. What type of angles did I just mark? Corresponding angles. And if they're congruent, it would mean these lines are parallel. Why is that not good enough to say that's a parallelogram?
Two sides.
I only have one pair. I need two pair to make a parallelogram. Everyone with me? We good? Two pair? Next one, 4 and 7. Where's 4 and 7? What type of angles did I just mark there? Alternate interior. That makes these lines only parallel. Again, I only have one pair. I need two pair. Keep going. 2 and 5. What did I just mark there? And that would make, let's see, boom, boom, these parallel. And 5 and 7. These are corresponding, which make these parallel. Now, do I have both pair of opposite sides parallel? Yep. What's that?
It would also make 2 and 7 congruent.
Okay, but that would only be one pair of opposite angles. I need both pair. Okay, I need both pair. Yep.
Number
10?
I just don't really know how to set stuff up. I know.
Okay, let's see. The obtuse angle that's formed by J Street. Remember, obtuse is what? Greater than 90. J Street forms with Brook Road. So J Street forms, here's the obtuse angle they're talking about right here, is 3 times the measure of the acute angle formed by J Street and Main Street. Acute tells me? Okay, so if I look up here with J Street and Main Street, this one's the one bigger than 90, this one's the one less than 90, agreed?
Yeah.
So this angle is 3 times that one, so I'm going to call this one X. And they show they are parallel, so these are called same side interior. Are they congruent or supplementary? Supplementary, so that's how I know to do this versus setting them equal to each other. Okay? Anything else? Okay. Nobody asked it. I'm not going over it. I just actually, it's not on this one. Was it on this one? Oh no, it's on the one your guys are gonna practice in class. So I'll talk about that in a second. All right. I only have 3 facts to go over with you today. That's it. 3 facts. And I'm done reviewing. Monday is your day. You want to ask me specific questions from the review packet, specific topics, or you're working on your own. I have nothing planned for Monday. All right, it's your show on Monday. Your show. So I wanted to just go over real quick with you the 3 triangle theorems that we went over in Unit 5. The 3 triangle theorems we went over. Let me draw the diagram, and maybe you can tell me the first one. What's angle 1 equal to, Sophia?
Angle 3 and 4.
3 and 4. I want to use some vocab now too. What do I call angle 1? That's an
Adjacent.
Oh, it's on the outside.
Oh.
Nothing fancy.
Exterior.
Exterior angle. It's an exterior angle, and it's equal to the sum of the 2 non-adjacent interior or remote interior angles. Okay, remote interior. Also, you can keep going a little further and say, all right, if angle 1's equal to 3 and 4, add it up. Angle 1, how does angle 1 compare to angle 3 just by itself? Greater than. And the same thing can be said for angle 4. The only thing I can't figure out is if 1 and 2 are big. Which one is bigger between 1 and 2? I can't tell you that. What is the relationship between 1 and 2, though? Supplementary, but I cannot tell you which one's bigger, though. All right, next theorem. How about this? I got a side of 5 and a side of 6. How about the third side? Can't be anything you want. Can't be 30. Can't even be 13. It's got to follow a rule. Anna?
You add 5 and 6 for the higher end, then you subtract 5 and 6 for the lower end.
That's how I'm going to find it. What's the theorem or what's the fact you're putting that into? Sum of two sides has to be must be, when I add two sides, it's got to be greater than, not greater than or equal to, greater than the third side. Okay, sum of two sides must be greater than the third side when I find it. So, as Anna just said here, to find the third side, you subtract these two. I get 1. So that third side's going to be between 1 and Adam, 11. But not including 1 and 11. So I subtract them and add them. And the final theorem, let me put that triangle back up now. 5, 6, and I'll pick 10 now for the third side. Can you tell me how the angles rank? And how do you know? Like the biggest angle, the smallest angle, can you tell just from those three sides? Okay, what is it? Biggest angle across from?
Underside.
Biggest side. And you could also substitute in the word smallest. All right, that's how I figure out where the biggest sides and angles are. And that's all I have. That's all I wanted to cover. I just want to give you a heads up. You are going to start review number 4. Just so we don't panic here, I want to make sure you're going to be off to a good start. I want to show you the type of proof I put on here. Not to waste your time because you probably will see it on Tuesday. If you look at number 12 on review 4. I don't know if this was on any of the other reviews yet. Everyone see the proof statement? Prove it does not bisect. What type of proof do we have here?
Indirect.
Indirect. Yeah, we're going to have to look at, remember how to do that. Because I'm not putting it on here to waste your time either. All right, that's an indirect proof, number 12. So it starts a little different after your givens. All right, let's roll. You guys know the deal. Have an answer key open. Have an answer key open.